Alright, so this is the next question that we're going to work on. We're still dealing with the questions where we have exactly a certain number of successes. Now we're going to move on to the next section, and it's going to be at least this many successes and at most this many successes, but don't worry about that yet. So right now we're still dealing with exactly a certain number of successes, and you're going to see the pattern as we just keep going. So every time you have a question like this, a spinner is spun 5 times, what is the probability that we get exactly 3 orange? So this is red and this is orange, green, and blue. So what I want you to do is same thing as before. I want to know what my N is. I want to know what my R is. I want the probability of success, which in this case it's the probability of getting an orange, and the probability of failure, which is probability of not getting orange. Okay? So those are the 4 things you're going to look for every single time you have a question like this. N is the total number of trials. The spinner is spun a total of 5 times. We are looking for the probability of exactly 3 oranges. Now, take a look at our spinner. What is the probability that I land on orange? Well, orange is only taking up 1/4 of the space, so it's 1/4. Meaning, what is the probability I will not land on an orange? That happens to be 3/4. Now we're going to use all these pieces of information and put it all together. The first part is NCR. 5, choose 3. In parentheses, the probability of my success, 1/4. And the probability of my failure, 3/4. Now, the exponents represent the number of times I want each event to occur. How many times do I want to spin and land on orange? I want exactly 3 oranges. So, how many times do I want to spin and land on orange? That's going to be 3. Well, if I'm doing a total of 5 trials and I want 3 of them to be orange, how many of them are not going to be orange? 5 minus 3 gives me 2. Then I can go through and simplify. 5, choose 3. 10. So that's 10 over 1 times 1 to the 3rd power is just 1. 4 to the 3rd power is 64. 3 squared is 9. 4 squared is 16. Then I can go through and multiply across the numerator and multiply across the denominator. 10 times 9 gives me a 90. And then in the denominator, 64 times 16 leaves me with 1024. That is your final answer. That would be an option on the test. More than likely, you will see answers left in fraction form rather than decimals on this test. Okay? So that 90 out of 1024 is the probability that if you spin spin this 5 times that you're going to get 3 oranges or land on orange 3 times. Alright, moving on. In a family of 4 children, what is the probability that you get exactly 3 girls? Okay, so we're going to set up this question exactly the same as we did before. I want to know what N is. I want to know what R is. I want to know the probability of success, which in that case, the probability of success is that I get a girl. And the probability of a failure, which is not a girl, or in this case a boy. Okay? So in a family of 4 children, so how many total trials do we have? We have a total of 4 trials, and we want exactly 3 girls. Now what is the probability that I would get a girl if I had a baby? That would be 1/2, and the probability that I get boy is 1/2 as well. Now let's use those values to set up our equation. First part is the combination. 4, choose 3. That says that you want to know all possible combinations of ways that this could occur. So girl, 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 boy, girl, girl, boy, girl, and so on. Now you do the probability of your success and the probability of your failure. each of which are raised to an exponent, and that exponent represents how many times you want something to occur. It said that this is our probability that we get a girl, and we want exactly 3 girls. So how many girls do we want? We want 3. Now if we have a total of 4 children and we have 3 girls, how many are left with to be boys? That would just be 1. Over here on my calculator, I can now simplify everything. 4 choose 3 gives me 4, so 4 over 1. 1 to the 3rd power is 1. 2 to the 3rd power is 8. And then anything raised to the 1st power is just itself. So here we go. The probability that I get exactly 3 girls if I have 4 kids is 4 out of 16. Okie dokie. Which is pretty cool. This is your next homework assignment. Homework page 577 to 579. That is homework 115. You also had another set for your homework. Homework 115 actually was 2 different sets of pages, so I don't know, maybe that has to do with the next section, so I would just wait a second before you do that, but that's homework 115. Moving on. Alright. This, I believe, is the last and final section, if I'm not mistaken. Yeah, the last section that we're going to do on this chapter. Alright, so hopefully that wasn't too painful for you. So what I want to talk about is what we just did. We just figured out the probability of getting exactly a certain number of trials. Well, that's not the only kind of question that you're going to see. Sometimes you're going to see things worded where, oh, you have 4 kids and you want to find the probability of getting at least 3 girls or at most 4 boys. I don't even know. So I want to explain to you the difference between at least and at most, because a lot of people kind of tend to get this confused. So if I had you over to my house and I said, alright, you need to make money, so you're going to help me out around the house, you're going to do some chores, and I'm going to pay you at least $50. It's a pretty good deal. Go mow the lawn, pay at least $50. What does that mean to you? When you hear the words at least $50, what does that mean? That means you're going to get paid $50 or more. That's a pretty good deal, because the lowest amount that you're going to possibly get paid is $50, but you could get paid more than that. Then I'm going to have my other friend over, and I don't really like him as much as I like you, and I'm going to say, alright, you're going to help me weed in the garden, and I'm going to pay you at most $50. Now, what is he hearing in his head? At most 50, that means that no matter how hard he's going to work, he's going to get $50 or less. So 50 or 40 or 30 or whatever. Alright, so there's a huge difference between hearing at least and at most, and you need to be able to recognize that when you're doing these questions. So if you're having a hard time, try to think about it in terms of money, because money always tends to encourage people, apparently. I don't know. Now, we're going to do the exact same thing that we did with the previous questions. We're going to set everything up exactly the same way, except for one little thing is going to change. And that is based on this at least part. And I'm going to explain that to you. Alright, so what is the probability that you get at least 2 heads in 3 tosses of a coin? So I want the same thing as before. I want to know what my N is. I want to know what my R is. I want the probability of success. So in this case, we're talking about getting heads. So that's the probability of success. And then the probability of failure in this case would be tails. Okay. Probability of heads is always 1/2. Probability of tails is always 1/2. My N, the probability that you get at least 2 heads in 3 total tosses of a coin. So my N is 3. Now, here's the part that's going to be different. This sentence says that you get at least 2 heads at least. If I pay you at least $50, that means you're going to get 50 or 60 or 70. It's 50 or more. So if it's saying at least 2 heads, that means I could get 2 or I could get more. I could get 2 or I could get 3. I can't get any more than 3 because we only are tossing the coin a total of 3 times. But at least 2 heads means 2 or 3. Now what does that mean in terms of what we're going to have to do right now? I'm going to explain that in just a second. Can I move this whole thing? Oh, check that out. Pretty cool. Okay, sorry. We're going to do the exact same thing as before, except for this time we're going to have to deal with 2 different values for R. So watch this. What I'm going to do is I'm going to set up the question exactly the same way as I did before and pretend that my R is set equal to 2. Okay? So the first part is combination. N choose R. So 3 choose 2. My probability of success was heads and my probability of failure was tails. How many times do I want heads to occur? What's my R value? I want 2 heads. Okay, well if I'm tossing the coin 3 times and 2 of them are heads, that means I only have 1 left over to be tails. Okay, no problem. Now what we're going to do is forget about that 2. Now we're going to focus on when R is set equal to 3. We're going to write out the exact same thing all over again. This time my R is 3, so it's going to be 3 choose 3. My probability of success and my probability of failure. Well, this time when my R is 3, that means I want to get 3 heads. So how many times do I want to be successful? How many times do I want to get heads when I flip the coin? That's going to be 3. Now if I'm tossing the coin a total of 3 times and I'm getting 3 heads, I'm getting tails 0 times. So the only thing that changed is because we have at least 2 heads, that means that I had 2 separate values for R. I had to write out the equation twice. And what am I going to do in between there? I'm just going to add them. Okay? Now we can go ahead and simplify. 3 choose 2 gives me a 3. 1 squared is 1. 2 squared is 4. Anything raised to the first power is itself. Now I'm going to go over here. 3 choose 3 is a 1. 1 to the third power is 1. 2 to the third power is 8. Anything raised to the 0 power is 1. Now the way that you know that you did these correctly is when you simplify these fractions. I get 3 over 8 and I get 1 over 8. When you simplify these fractions, the way that you know that you did it correctly is you have the same denominator. When you're adding these fractions, you always have to have a common denominator, and in this case you never will have to change anything. You always will be given the common denominator. So you just add the numerators together. That is 4/8. Do not simplify that down to a half because more than likely that will not be an answer on the test. 4/8 will be your answer. Alright, so it's pretty much the exact same thing that we were doing before, except for the at least part right here, changed it and made it so that we had multiple values of R. And I'm going to stop and then we can do more problems together.